All right, class. So let's move on to the next part, which is a support vector machine with Python. So remember that the purpose of this support vector machine is to be able to find this hyperplane, right? If we're talking about a two-dimensional space, it's just practically a linear line. And then if we're talking about a upper dimensions like 3 or more, then we're talking about a hyperplane. All right, so let's do first the import. So we're gonna import some libraries. So we're gonna do the import for pandas and as pd. We're gonna import numpy as nympy. We're gonna import matplotlib just in case we need it. .pyplot as plt, and then we're gonna import c born as s and s. We're gonna do a matplotlib inline just to check that this is correct. We're gonna run it. Now we're gonna import some data from the sklearn. So we're gonna do from the sklearn dot datasets. We're gonna import load breast cancer, load breast cancer, and then we're gonna import the data and save it into this cancer data, load cancer, breast cancer. So we're using some data from like some cancer patients, breast cancer patients. So now the data is stored in cancer. We now let's look at some of the columns that we have for this cancer, right? So we're gonna have cancer dot keys just to see what are the what kind of features do we have. So we see we have data, target frame, target names, feature names, file name, data modules. So the data is actually presented as a dictionary form, so that's why we can pull out the keys. And now what we're gonna do is let's see what we have for the description. So we can look at any part of the data because it is a dictionary. So we're gonna use the name of the keys to be able to access the values. As we can see here, we can it's gonna automatically give us an option. So that's gonna use description, and we're gonna be able to see what does the cancer description tell us. So this is telling us, everything about the area, smoothness, compactness, so on and so on. A lot of information about that, and then we can also do the cancer features. So we can do cancer features names. And now we're gonna look at this. We're gonna start setting up our data frame. So df, we're gonna call it df features. And we're gonna extract the information from our cancer dictionary. So we're gonna create this data frame, which is from pandas. Cancer is a dictionary, so we're gonna grab the data from the data. So that's going to be, and then our columns will be from our cancer features, feature names. And now we can see what does it look like, and we're gonna let's actually see the information. def feature.info, and now we can see what kind of data do we have here. You can see here we have every single feature has the same amount of data, so we don't have to clean it up. It seems like it's well cleaned. Everybody has the same numbers. We can see the features of the data here, and now we can see our target values. So let's see our target values. Answer, target. So this is going to represent our target. So either you have cancer or you don't have cancer. And so what we want to do here is now we're going to create a data frame for our target. Now that we can see that we've seen it, we're going to set it up as data frame cancer target Columbus. Oh, I'm sorry, columns equals to cancer. So we're going to define this data frame as column cancer. And then we're going to look at our data frame, df data frame, or head, sorry. Sorry, dot. What's going on here? What's going on? Oh, I think I meant to say D featured. There you go. All right, so now we can see this is your features, your columns, your feature. And then we have our target, which is going to be represented by the data frame target. Now what we want to do is we want to train or split our data, but first we need to import the sklearn model selection import train test split. And we're gonna split our data with 30% testing and the other the 70% of training. So we're gonna do x train x test y train y test, and it's going to be equal to my train test split with my DEF features and my np dot label of my DF target. Again, my test size is going to be equal to 30%. And it's going to be randomized with the random state of 1 or 1. So that way you guys can get the same results as I do. And now what we're going to do is we're going to extract our model. So from the sklearn, we're going to export the support vector machine. Oh. All right, and then we're gonna define our model to be as support machine. And then our model fit x train y train. right? So this is we're training our model. So we created our model here of type support machine, and then now we're feeding our model. We're training our model with this data X train and our Y train. So this is where we're supposed to get. This is the features, and we're trying to create this hyper plane. And so we're gonna find our predictions equal to model dot predict, and we're gonna use our X test to train our model to make our predictions now that we have trained it. And ASCII learn matrix import classification report, and we're going to do also import the confusion matrix. So remember, this is just ways to be able to measure our accuracy in our model, and then we're going to print the values of our confusion matrix. For our comparison between Y tests and our predictions. Let's see how well we did. So it seems like we got 56 and 102 that are correct, and then 10 and 3 that are incorrect. So this is true positive, true negative. So that's good. And now what we're going to do is we're going to measure our predictions we call F1 score. And so the way we do that is we print it and use the classification report and pass in our values Y test and predictions. So we're gonna stop there. We're not gonna do the grid search part of it. But yeah, so this is actually pretty good. It's not bad. So we're gonna leave it at that point. Okay, I'll see you guys next time.